Across the scientific community and beyond, the dwarf planet Ceres has fascinated researchers due to its massive size, unique location, and, most intriguingly, mysterious lights that appear to be artificial. Could this be the breakthrough that transforms our understanding of the universe? Are we on the verge of uncovering the secrets of extraterrestrial life? By exploring NASA's groundbreaking findings, we may soon learn the truth about these enigmatic lights and their implications for the future of space exploration. The journey to this discovery began in 2007 when NASA launched the Dawn spacecraft on a mission to explore some of the most captivating objects in our solar system. Equipped with 3 ion engines, Dawn was designed for a groundbreaking journey, starting with an in-depth 14-month study of Vesta, the second-largest asteroid in the asteroid belt. The spacecraft sent back a wealth of high-resolution images and data, revealing Vesta's complex surface and rich geological history, including massive impact basins, towering mountains, and deep grooves that provided insight into the early solar system's violent past. As the mission at Vesta concluded, Dawn embarked on the second phase of its journey, one that would capture the attention of scientists and the world alike. With its advanced ion propulsion system, Dawn departed Vesta's orbit and set course for its next target, the dwarf planet Ceres. Unlike traditional chemical propulsion systems, ion engines provide a continuous yet gentle thrust, allowing the spacecraft to travel great distances and ultimately enter a stable orbit around Ceres with unmatched precision. This technology allowed Dawn to maneuver more efficiently than any previous spacecraft, making it one of the most ambitious and successful planetary exploration missions in history. Discovered in 1801 by Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt, lying between Mars and Jupiter. Initially classified as a planet, then an asteroid, and later reclassified as a dwarf planet in 2006, Ceres has remained a subject of scientific intrigue. With a diameter of approximately 950 kilometers, it is the most massive body in the asteroid belt and holds the potential to offer crucial insights into the early solar system. Scientists speculate that Ceres may have once had an internal ocean, raising questions about whether it could have ever supported microbial life. As Dawn approached Ceres, anticipation grew. The spacecraft was about to send back the first ever close-up images of this mysterious world. One of the mission's primary objectives was to enhance our understanding of planetary formation, particularly the role of water in shaping celestial bodies. Among its most striking discoveries were the bright spots concentrated in a large crater known as a crater. These luminous patches were unlike anything previously observed, sparking intense speculation. Were they evidence of active geological processes, or did they hint at something even more profound? Before Dawn's arrival, Ceres had only been seen in low-resolution images captured by the Hubble Space Telescope. With the new high-resolution images, the mystery deepened. Could these bright spots indicate something far more complex than previously imagined? Scientists proposed various theories, including the possibility of highly reflective salt deposits left behind by sublimated water. This discovery suggested that cryovolcanism, volcanic activity involving water, ammonia, or methane rather than molten rock, could be occurring on Ceres. Could Ceres be home to active ice volcanoes? Could the bright spots signify ongoing geological activity? Or do they hint at something even more extraordinary? These once unanswerable questions suddenly seemed within reach. The reflective nature of these deposits suggested that briny water had made its way to the surface in the relatively recent past. If this process is still occurring, it could mean that Ceres remains an active world, reshaping itself over time. Ceres stands apart from other bodies in the asteroid belt due to its composition, which bears similarities to comets rather than rocky asteroids. Scientists believe it contains a significant amount of water ice beneath its surface, making it a prime candidate for further exploration. The presence of ammonia-bearing clays also suggests that sears may have formed in the outer solar system before migrating inward, offering new clues about planetary migration and evolution. This finding has profound implications for understanding how icy bodies move through space and interact with other celestial objects. After nearly 8 years of travel, Dawn finally reached Ceres in early 2015, marking a major milestone in space exploration. As the spacecraft drew closer, the images it transmitted became increasingly detailed, revealing a world long shrouded in mystery. Ceres' surface is covered in craters, ridges, and fractures, each telling the story of its complex history. However, the bright spots in a crater remained the most captivating feature, continuing to puzzle and intrigue researchers. As Dawn's resolution improved, scientists discovered that the brightest of these spots was not a single feature but a cluster of multiple distinct deposits, each with unique characteristics. The most widely accepted theory is that these bright spots are salt deposits left behind as briny water sublimated upon reaching the surface. This suggests that Ceres may still experience geological activity capable of bringing water or brine to the surface, altering our perception of this distant world. This raises the possibility that Ceres could still be undergoing changes that we are only beginning to understand. The potential presence of subsurface water raises a compelling question: could Ceres harbor conditions suitable for life? While it may not support life as we know it, its unique environment provides valuable clues about the habitability of other icy bodies in the solar system. If brine pockets exist beneath the surface, they could serve as analogues for other extraterrestrial environments, such as the subsurface oceans of Europa and Enceladus. These moons of Jupiter and Saturn are considered some of the best places to search for extraterrestrial life, and Ceres may share similar characteristics. Cryovolcanism, a rare form of volcanic activity, adds another layer of intrigue to Ceres. Unlike traditional volcanoes that erupt molten rock, cryovolcanoes release water, ammonia, or methane, which can exist as liquids or gases in extremely cold environments. The bright spots in a crater, particularly one known as Spot 5, have drawn significant attention due to their high reflectivity and periodic changes observed by Dawn. Scientists believe that water sublimation plays a key role in these changes, indicating that cryovolcanism may still be occurring, or at least, did in the recent past. Beyond a crater, several other bright spots are scattered across Ceres, suggesting that cryovolcanism may be a widespread phenomenon rather than an isolated event. This challenges previous assumptions that the dwarf planet was geologically inactive, painting a picture of a more dynamic and evolving world than we ever imagined. As Dawn continued its mission, more surface features emerged, providing deeper insights into Ceres' geological history. Craters, ridges, and fractures tell a story of cosmic impacts and internal processes shaping this enigmatic world. With each new discovery, our understanding of Ceres, and the solar system as a whole, expands, raising even more questions about the potential for life beyond Earth. What do you think about these discoveries? Could Ceres be a key to understanding the broader mysteries of the universe? The search for answers continues, and each new finding brings us closer to unveiling the secrets